Greetings, everyone. This is Matt St. Onge from Red Hat, welcoming you to today's open demo session, Best Practices for Running a Highly Available PostgreSQL in Production with Ansible Tower. With me today, I have Jonathan Katz, Director of Cloud Engineering and Growth from Crunchy Data. And over the next hour or so, we're going to show you a joint solution between Red Hat and Crunchy Data, and hopefully give you a little bit of shock and awe, some wow factor, and more business case for making that Ansible Tower of yours highly available with Crunchy. A little bit of housekeeping before we get started here. Go through some introductions. Everyone's been muted on entry. We're recording today's session. If you have questions, concerns, comments, please put them in the chat, and I will share them with Jonathan, and we'll get them answered. What we're going to do after we finish housekeeping, there's a raffle. Every month, our open demo series, we give away Amazon gift cards to attendees. So there's going to be a link we're going to put up here shortly. Be sure to go and register and get a chance at getting a free Amazon gift card, because that's where we all do our shopping, I guess. And one more slide. So a little bit about myself. I am in the ISV Alliances team, which basically means I support our independent software vendor partners and our embedded systems partners here at Red Hat. My focus is on partner enablement. So I work directly with engineers, architects, the techie guys at our partners, and I basically do a train the trainer kind of role with them, and I help them work their solution along with Red Hat products, create a joint solution, and with our teams together, we jointly market and support our customer base. I've been doing this in the open source community now for about 25 years. This is my 5th year at Red Hat, actually. I'm glad to be here. Thank you all for joining, and I'll let Jonathan introduce himself.
Thank you, Matt. So, hi, my name is Jonathan Katz. I'm the Director of Cloud Engineering and Growth at Crunchy Data. Before that, I was a very active Postgres user at several startups in New York, and that's how I got involved in the Postgres community. And my role in the community has been a lot around advocacy and things pertaining to helping to get Postgres out the door, writing the press releases, and so on and so forth. At Crunchy Data, I took a lot of the learnings I had from running Postgres in production, and I applied that to our cloud engineering team, where I focus on deploying Postgres in automated and scalable ways, such as with our Postgres operator and with our Postgres platform, which I'll briefly mention later on.
Great. Hit the next slide. And as I mentioned, we'll leave this slide up here for a second. If you like, please go out to this link, https://November_raffle, and sign up for your chance to win a free $50 Amazon gift card. It's our way of saying thank you for joining our informational session. That up there for a few seconds, and then I'll let Jonathan take it away. Back to you.
Thank you, Matt. So here's a redundant title slide. So basically, we're going to talk about best practices for running in Postgres in production with Ansible Tower. Now, in the live version of this talk, I usually like to begin to ask how many people are running Postgres in the room. And I start asking more specific questions, such as, are you running Ansible Tower? Are you running Quay? And then, add on like, oh, by the way, you're running Postgres as well. Since, unfortunately, I can't poll the room, I'm going to dive right into it so we can talk about, the importance of creating a highly available Postgres environment and, what it means for, keeping all of your services up. And, of course, most importantly, a demo. So just, again, briefly about me, I've been at Crunchy Data for almost 2 years now. I'm our Director of Cloud Engineering and Growth. responsible for a bunch of our engineering efforts as well as our marketing efforts. And a lot of my experience I bring to Crunchy comes as a Postgres end user, just deploying Postgres in production systems for many years. It's one of my favorite open source technologies, maybe a little bit of an understatement given my involvement in the Postgres community. But for me, it's like I love working with Postgres, and in Crunchy Data, it's all about working with Postgres, which leads into our About Crunchy Data slide. And one of the reasons why I love being here is what we focus on. Crunchy started ensuring that Postgres could be deployed securely, which is very important both in federal systems as well as in enterprise solutions. Especially with all the regulations around data and protecting consumer privacy and so on and so forth, it's important that you know how to deploy Postgres securely. Then there comes cloud, this cloud-ready data management, and that's being able to take those learnings from how to deploy Postgres appropriately in an enterprise environment and do it 1,000 times over. Last but not least, all we do is open source. Everything that we're going to talk about today is an open source product with an open source solution. And Crunchy basically adopted the Red Hat model of basically saying open source is the enterprise way to go. Postgres is an enterprise database on its own. We just contribute to the upstream. And that's one thing. Again, not to basically say that everything you'll see today you can try it on your own, but we're going to show how to make it very easy to deploy an HA Postgres environment. So I'm going to pull back a second and just talk a little bit more about Postgres, which I like to call an oldie but a goodie. So Postgres is over 30 years old. Actually, I'm roughly the same age as Postgres. And much like Linux, it's open source, but there's no single venue. It's not open core. It's open source. It has a very flexible license. It's a BSD derivative license. Postgres actually has its own recognized license. And what's changed really over the past 5 years is that Postgres is, even though it's been around for a long time, open source for a long time, it has had a very healthy and active development community. Something changed, and there were some market forces that helped with this, but Postgres itself just came to feature parity with many of the popular proprietary enterprise databases, and this caused people to look more at it.
So would that have anything to do with Oracle changing its licensing?
I think one of the catalysts was when Oracle bought Sun, because Sun had bought this little company called MySQL. And I think once MySQL was property of Oracle, that changed how people looked at, people started looking for alternative databases. So that all said, even before, Postgres started having more, feature parity with, a Microsoft-based database or, Oracle, Postgres itself has always been very extensible, and that's been the ethos of the community, that, the community will try to add as many features as possible, but allow people to develop their own features alongside Postgres, such as backup management solutions or high availability solutions. That said, there's, the core of Postgres is really about data integrity, transaction safety, ensuring that when you write a one to the disk, that one gets saved to the disk. If you write, a string to the disk, that gets saved to the disk in its true format. And actually, it's been a long time now. I think it's been over, almost 8 years. Postgres added support for the JSON data type, and even before was able to handle XML data types, and this custom key value data type. So it's been handling, the typical NoSQL workloads, pretty much since the dawn of quote unquote NoSQL. So it's very robust. It can handle all sorts of data thrown at it, and most importantly, that data will be secure and get written to disk. People are recognizing it. There's been accolades being thrown at Postgres, and it's only continuing to rise. By the way, Red Hat has noticed this too. As you can see from the Ansible Tower documentation, one of the dependencies is Postgres. In fact, Postgres is the only database that is backing Ansible Tower at this point. You see this in some other Red Hat products as well, such as Quay, and
which is now open source too, officially, by the way.
Oh, cool! I did not know that. And actually, our, in addition, an important point, I forget if I put this in the slide, but the Crunchy Data HA solution we're going to present today is both certified for being used with Ansible Tower and Quay. So yeah, it's, for me, as a, longtime community member, I'm excited to see, the continued adoption of Postgres. And as, as a Crunchy Data employee, I'm also very excited because I get to work on some very cool solutions that can help ensure your data is stored safely and is always available. Speaking of, what does it take to run a database in the enterprise? I break it down to 5 features that are, the bare minimum requirements to have an enterprise class database system. The first is provisioning. You need to be able to create a database. You also need to be able to destroy it, and hopefully you're destroying one that you intend to destroy, not your production database live.
Whoopsie.
Yep, that does happen. You need to be able to configure it. You need to be able to, of course, apply upgrades. In fact, Postgres has an upgrade release coming out this Thursday, so you should definitely plan to upgrade. Important bug fixes. And you need to administrate it. You need to be able to add users, or drop an index or create an index, or whatever it may be. High availability, making sure that your database is always up. You can always read to it, you can always write to it, and if you have downtime, that you're not losing any transactions in the process.
Keyword being resilience.
Resiliency indeed. Disaster recovery. And actually, I would, after provisioning, I would actually put disaster recovery before HA in terms of importance. That you always need to back up. And more, almost as importantly, you need to be able to restore. And particularly if something happens and your multi-terabyte database and you need to bring it back online, you want to be able to ensure that restore is able to happen quickly.
Especially if someone accidentally destroyed the wrong part of the
database. Drop table users without being in a transaction can be pretty bad.
Should have done that select all statement.
Yeah. So, but backups are very important. Usually, I also poll the audience here to see how many people are taking regular backups of their databases, and make a strong suggestion to do so. Monitoring, being able to anticipate problems before they happen, having health checks on your database, being able to see, how much of your RAM is actually being utilized. Is a particular query, pegging the CPU, and can you fix that? And authentication. Postgres itself has a very strong authentication system where you're able to plug in, all sorts of methods, be your Active Directory Kerberos-based system, or your PKI system, or if you just want to use passwords. And one of my personal plugs I love to make is to use Scram from Postgres 10 and beyond, which is a much better password management. So a typical enterprise environment would look like this. Let's say you have a single data center. You have several Postgres nodes. You have one primary, several replicas. You have PG Backrest. It's an open source enterprise grade backup tool. Basically, archiving everything, keeping your backups. Let's say you've hooked up your Ansible tower to it, and as you see, nothing here has a single point of failure. What if I said we could build this in one step? Well, you'd probably say, show me. And then I would tease you this line, basically this line to run an Ansible Playbook. Now, I love to do this live, but I also like to be cautious as well, particularly since it's being recorded. So I went ahead and ran this command. But I'm going to step you through what the inventory file for this looks like and what the playbook for this looks like so you can understand what's going to be going on. So what happens? So this is my inventory file. Basically, I set up, the various passwords for my environments. I give definitions for my clusters, or I basically say, what to call my clusters, where they're located, what their IP address is. And then I have a playbook. And the playbook loads a series of roles. This is part of the Crunchy HA Postgres solution. So it loads a series of Ansible roles and executes them and gets everything installed and configured and set up. And it does it safely. Particularly when loading your Postgres clusters, you do want to do those one at a time, but all the others you can do in parallel. So this takes about 12 or so minutes to run. And the whole idea of this presentation is we start running the command, and then we come back to it later. Of course, let me get into the correct presentation view. Oh no.
Murphy's Law always.
Yeah, well, I think every time I'm going to quit out of it, I'll probably have to do that again. So anyway, let's pretend that we're running, running the playbook, and it's going to provision successfully. I did run this last night. Actually, I ran it twice last night to make sure everything worked, and it does work. So what's the motivation for Crunchy HA Postgres? Like, why did we develop this solution with Ansible Automation? Well, the problem is that databases in high availability are not simple. Even if you look at some of the proprietary solutions out there, they're composed of many moving parts. And the importance is that stateful workloads have one job: maintain state. Particularly if you're familiar with the Kubernetes and OpenShift communities, they talk about the complexity of handling stateful workloads, which is why they worked on stateless workloads first. And this is true because particularly for business continuity, if you lose or corrupt your data, like there might not be any business to continue. And particularly if you don't take backups, you really could be, out of a job. So again, I say many times during this talk, ensure you have your back. If there's one takeaway from this, make sure you back up your data. Anyway, specific knowledge is required to perform state modification operation. What is, and what do I mean by that? Well, what does it mean to provision a new cluster in Postgres or take a backup? Like, what do you do? No, it's not necessarily as simple as copying your data on a file system, but there's a series of steps to ensure that you're maintaining the appropriate state. Even within Postgres itself, if I insert a row, what does that mean? How do I ensure that that insert is propagated both to the file system and to my write-ahead log, to my archive, to my replicas? And basically, the whole thing around ensuring your database is highly available is ensuring that you can make your data always available without corrupting it. That's what we're trying to do at the end of the day. So let's take an example of what a state modification operation, and we're going to provision a Postgres cluster, or we're going to look at the steps to do so. So first, you need to provision your environment. It could be your virtual machine, it could be your container, it could be your bare metal system, because there are people who still run those. I mean, there are many good uses for bare metal. You then need to install the software, so you install Postgres within that environment. You need to initialize your database directory, which is where Postgres stores its files. I like to call this an instance, and you run this with the initdb command. You'll probably need to modify your postgres.conf file that gets generated after you run initdb. You want to take advantage of the 128 gigs of RAM that you might have on your server, so you set the settings appropriately. Then you start the cluster. When you start the cluster, it's probably not ready for prime time yet, because the only user you have available is your super user, and you should not let your applications connect as a Postgres super user. Takeaway number 2 for this talk: do not let your applications connect as a Postgres super user. So you're going to add a lower privilege user to the cluster. Great. But now you need to make sure that the user, has a database to work in. They're not going to be connecting to the super user or the primary catalog database. So you create a database, you give that user ownership. You now need to make sure the user can connect. So you need to update your authentication rules, which is in a file called pghba.com. Then you reload the cluster configuration, and you're good to go. So creating a database isn't exactly a simple step. It actually took us, 9 of these steps to get there. And that is a process that, in a production environment, you would likely automate. Now, and let's say, you're going Postgres first in your system, you'll probably need to do this all day, which means that you need to do this process, thousands and thousands and thousands of times. But then what if someone needs to take a backup? Or what if you need an HA version of the database? Or if you want to set up, monitoring? This is where we can automate. So this is the crux of the Crunchy HA Postgres solution, is that it utilizes Ansible automation to provide all those essential database as a service functions. The automated deployments. You don't want to be running that initdb command the way I showed you every single time. Being able to handle failover automatically, or promotion and healing. And that's an important aspect of it too, is that for instance, if we have to fail over a workload where we have a 10 terabyte database, we want to be able to heal the old primary. We don't want to necessarily have to restore it from scratch, because that could take a long time. So being able to heal and say, like, okay, you missed 10 gigs of transactions, but we can catch you up and bring you up with the rest of the cluster. That's very important. Advanced disaster recovery capabilities. For instance, being able to do a point-in-time recovery. The whole drop users example, where if I drop my user table, well, I want to be able to restore my database back to the time before I drop the user table, but not necessarily have to rebuild the entire cluster or just throw out the application. Handling load balancing and connection pooling. Load balancing, I think, is much easier to understand in the database world, in the sense of that I send, my writes to one of the servers and my reads I distribute across the other servers. With Postgres, connection pooling becomes important because of, its model for how it handles connections, particularly on the Postgres server itself. It always forks a process when a new connection is made. So to limit the amount of, connections that are open, so to speak, there's a great connection pooler called PG Bouncer used to do that. PG Bouncer also does a little bit more than just connection pooling, which we'll cover a little bit later. And of course, monitoring and alerting. That we can set up a great monitoring environment with an open source library called PG Monitor, and you can plug in your alerting system to that as well. And that's the key of all of this, that these are all trusted upstream open source components, or as I like to say, the best of the best.
But supported by Crunchy.
Supported by Crunchy.
Which makes it enterprise.
Exactly.
क्या बोले?
So why use CrunchyHA Postgres? So first, I think the point that I've hit home so far is it automates the creation of the HA environment. With that, simple command that we saw, earlier, we're going to see that we have a multi-node Postgres cluster set up. There's even more complex environments we can create that, we'll cover as the talk continues. Another important thing is standardization, the process of how the Postgres environments are provisioned and managed, and this is key. You could probably go out and build, all these Ansible roles yourself, but what we do here is that we create a standardized workflow for you with the CrunchyHA Postgres solution. Additionally, the team that works on this is all that they do, that they battle test it. They test all sorts of weird scenarios to avoid, for instance, like a database split brain, which is, probably, the hardest one to recover from, of all of them. Between that and corruption, split brain is a doozy scenario. But also, provide flexibility, and that's one thing that, is part of the Crunchy ethos is being able, and also the Postgres ethos is choosing how you want to deploy Postgres. Maybe you have a single data center environment, maybe you have, a lot of large nodes where you want to have multiple Postgres clusters running on them, but still distribute it. Maybe you have a multi-continent environment, but no matter the choice, that, these roles provide the flexibility for being able to handle this deployment. An important thing, going back to enterprise grade, is applying compliance rules uniformly across your Postgres cluster. Part of the Crunchy certified Postgres solution is that you're able to basically check all the boxes required for these secure enterprise deployments, ensuring that people can only authenticate a certain way, or everything is audited using the PG audit extension. And last but not least, using trusted open source components. These are, again, very similar to Red Hat. We basically find, the best components. We do our best to support the upstream, and then we provide the optimal way to deploy them for your enterprise environments. So I keep saying this open source thing. So which are the open source components that we have? The first is Crunchy certified Postgres, which is common criteria EAL2+ certified open source Postgres. And that's really the secret of it. It is open source Postgres. It's not, we're not forking it. It's, the upstream. And we just, we got a common criteria certified. PG Backrest. So, it's a backup restore management solution. It was designed for terabyte scale data sets. It came out of a company several years ago that was pushing, several terabytes of write-ahead logs a day, and they needed something much more performant in order to, handle, the types of backup restores that they need. This has become the de facto solution in the Postgres community for managing, backups and restores, and it's something actually I was a fan of even before I joined Crunchy Data. PG Monitor. PG Monitor is a Postgres monitoring library. It basically packages together a series of Grafana dashboards that we've helped to develop, along with Prometheus and these Postgres exporters that basically pull the key metrics out of Postgres in order to visualize. PG Bouncer, which is a connection pool and also a state manager, and that's the thing I said I was going to get back to, that during a failover scenario, you can tell PG Bouncer to pause your connection, so that way it doesn't, you're not trying to write to a node that's down, and then when it comes back up, it's able to replay that without you losing that transaction. HA Proxy. HA Proxy helps with the load balancing to perform, this is probably even borrowed from their website. It's perform and durable TCP proxy. I've also used it in production environments and have had very little issues. We use a tool called Petroni, which is an HA framework that implements the RAF consensus algorithm and basically allows for Postgres to be deployed in a highly available manner in a way that uses a distributed consensus protocol. We'll touch more on that thoroughly shortly. And last but not least, etcd, which Petroni works with in order to provide that distributed consensus. So let's get...
It's a lot of really cool tooling.
Yeah, it is. And now we're going to see it all in depth because we can go way into it.
Uh-oh, he's rolling up the sleeves. Here it comes.
Yep. So how does Crunchy HA Postgres work, in depth? I mean, and again, first everything starts with provisioning.
I have a small question here. Can you hear me?
Your question?
Can you hear me? This is Virender. I'm from Blue Cross. Yes. There's a question.
Okay.
So how So when you say high availability, HA means high availability, right? So we have a scenario that Exadata data can it be transported to Postgres high available? Migrate, is that can support or collect the data?
Yeah, so I actually asked if you can hold on to that question for a bit. I'm gonna cover the HA scenario, fully
Yeah,
in
sure.
depth, as we go through. Thank you. So first we got a provision, and before we get to HA, we need to make sure that we have the entire environment set up, and that's essentially what happens when you run the Ansible playbook. So the inventory file, as you saw earlier, provides all the different essentially all the nodes that are going to be in your cluster, the IP addresses, the various labels, and so on and so forth. You can even get more specific in that as well, and basically dictate how you want those nodes to be deployed. For instance, if you want synchronous replication set up across your clusters, or asynchronous replication, or some base quorum commit. And basically, this configures every single node that's going to be deployed in your HA environment. So, for instance, the firewall rules. How you want to make sure people can actually connect to your instances, but you don't want to necessarily open up more ports than you need. The various HA components, the disaster recovery components, and of course Postgres itself. Everything gets deployed with the correct configuration. And that's part of the magic of using Ansible as well, is that you can create these consistent, uniform environments. So then so let's say everything's up and running and it's great, and this is something we're going to demo as well. But just to talk about it a little bit in depth before it happens, we get to a scenario where maybe we kick over a node, the primary node, and everything goes down. Maybe we have some sort of scheduled failover scenario. For instance, the Postgres update's coming up that, I want to upgrade Postgres to a newer bug fix version. Patroni, which is the HA framework that we use, utilizes the Raft consensus algorithm. And, Raft is basically designed to be a simpler version of the Paxos distributed consensus algorithm. So, mainly to be, easier to implement. And basically, it provides a safe, fault-tolerant way of managing availability. The key thing for me is that it helps, it avoids split brain scenarios. That if it's implemented properly, you're not going to promote two primaries at the same time, or get to a point where you have two different timelines that your users are connecting to, and that is really hard to recover from. Once that happens. Just as a fun fact, during when I give this presentation at Ansible Fest, I wasn't able to get the demo working, and I ended up doing like a half-interpretive dance of how the Raft algorithm works. But fortunately, we'll be able to see everything working shortly. Not cool.
No Murphy's Law.
No Murphy's Law. So if a primary is determined to be down, Crunchy HA Postgres does, basically pulls the plug. It basically says, all right, we basically have not been able to reach consensus on the primary. Let's start an election. So Raft is basically each node that's available is going to nominate itself to be a candidate. And basically, it's gonna promote the node that has the most recent changes. So that way, this is to prevent any transaction loss. Once it's safe to bring up the new replica, or basically the old primary, Crunchy HA Postgres detects that, oh, okay, this has come up, but don't rejoin the cluster as a primary. You're going to be a replica, and we need to heal. So we basically need to catch you up to the point of which transactions actually were distributed, and bring you up to like the latest and greatest transactions. Disaster recovery. So as mentioned, we use the open source PG Backrest tool. And, PG Backrest offers a few different ways to take backups. There's full backups, which is I want to back up, 10 terabytes of data. Incremental backups, which is I want to back up everything that's been taken since the last, type of backup that was taken. And differential backups, which is similar to incremental backups, but, basically shows the diff between everything. You can also back up and restore in parallel, which is a very robust feature of PG Backrest, and you can perform point-in-time recovery. PG Backrest also validates the backup integrity. So basically, it takes checksums on every single archive that's placed in the directory to ensure that there's no data corruption, and also allows backup rotation and archive expiration as well. So you don't get for instance, if you want to expire, every 21 backups, you can do that. Crunchy HA Postgres, basically, let me back up a second. So PG Backrest lets you deploy to your recovery storage of choice. You can deploy to an externally mounted file system. You can deploy to S3 or anything that speaks to the S3 protocol. And CrunchyHA Postgres lets you determine how you want to be able to deploy that. So monitoring, easily the most visual of all of these things. Basically, PG Monitor, which is a monitoring solution for CrunchyHA Postgres, lets you visualize what's going on with your database, and this is something we're going to see in the demo. So we're almost to the demo. I do want to cover a few different architectures that we can deploy. So the one that we're going to be seeing today looks like this. It's the single data center or single availability zone version of CrunchyHA Postgres. Fairly straightforward. But let's say you're in multiple data centers or multiple availability zones. Well, there's a playbook for that. We're able to do that and ensure that you don't and basically you don't put your data into a situation where both data centers become active and you have again a true split brain scenario. And then there's multi-continent, which can get very complex very quickly. Particularly when you have two active data centers in one continent, and you have your active continent and two standby data centers in the other. But we do have a playbook for that. We've tested this. This works. I believe we have. I know of at least one customer running this in production.
So we have a question coming in over the chat from Prem. And Prem's question is, how many DBs are required for HA? Is it just one primary and one replica, or are there multiple replicas supported?
So typically we recommend having at least 3 databases, one primary and 2 replicas. And the reason for that is, generally when you read the RAF paper, they suggest you have 5 instances of everything up, but then they try to suggest having odd number instances. We recommend 3 because we know that data footprints can get very big, and having 5 Postgres instances running might be overkill. But 3 is typically the right number because it allows for the scenario where something's happening and 2 nodes go down at once and another can come up fairly quickly. Also dealing with something like a typical scenario like a rolling upgrade where I need to update my version of Postgres. Well, I know that while one of those nodes is down, there's always 2 up, as opposed to really having a true single point of failure. So having at least 3 keeps you as much as possible from being in the single point of failure scenario.
So with the slide you have up, Jonathan, could you explain how the type of replication used is actually supporting multi-continent? Because from what a lot of people have seen, synchronous isn't going to work except in very short range.
Yep, that's correct. So what's great about this is that Postgres can use both synchronous and asynchronous replication at the same time. So in continent, in let's say active data center 1, the 3 Postgres nodes that are there are all using synchronous replication. But when it's replicating over to the standby data center, actually, let me back up a second. So in active data center 2, that's actually using asynchronous replication to go across the data centers. But if you look at the multi-continent lines, they're pulling from the disaster recovery system. That's essentially one of 2 ways that you can handle it. You could do an asynchronous link across continents. You can also just read from the archive. And actually, we know of cases where people use PG Backrest in lieu of Postgres streaming replication because they've actually had PG Backrest pushing more performantly to their standbys. That's an extreme scenario where I think this person is pushing 1 terabyte of WAL per hour. I think most workloads do not do that. But it's actually kind of a big shout out for PG Backrest that it can handle that.
Impressive.
Yeah. Does that answer the question?
Oh, yeah. Cool.
So shall we demo?
Are you feeling lucky?
What's funny is actually I was just watching Dirty Harry with my father-in-law, so I do feel lucky.
Just a reminder, if anyone else has questions, comments, please put them in the chat, and we'll get them addressed. Thank you.
Okay. So here's my demo. Everything is still up.
You adjust the font, maybe make it a little bit more legible.
Sure. Hopefully it works across the board. No. Okay. If this is the only thing that's tough in the demo, then we're doing good.
Yes.
Okay. So actually I need to get into my node. All right. So I think an easy way to begin is with an overview, looking at the monitoring. And PG Monitor basically shows us that all of our nodes are up, all of our nodes are healthy. We have 3 etcd nodes, 3 Postgres nodes, a backrest node, an HA proxy, and a PG bouncer. I didn't do the full HA proxy cluster and PG bouncer cluster due to I am pushing the limits of the memory on my machine. We can also see that currently our, in terms of the leader of our cluster is the PG2 node. So we can connect to that node, and there's a few ways we can connect to that node. One is via the PG bouncer, or one is directly. So I believe I have this in the history. Nope, okay, well, fortunately, I also know the address of the PG bouncer off the top of my head. Voila, so actually I set my PG password. Actually, just to show you there's nothing up my sleeve. I set my PG password file with my super secure password to connect to my AWX cluster. So let's connect. So I'm connected via the PG bouncer, and the PG bouncer knows which node to connect to. I have a table. It's going to be our sensor data table, and it's working. It's nice. So I have an application. The hardest thing for me in the demo is this part, resizing the screen. I feel like we're doing okay. So I'll show you what my application does before we run it. If it's in there, cool. My application is fairly simple. Basically, we have a counter. We're reading things from a sensor, and we have a counter, and we're going to say when we're inserting it and when it's committed. And if our connection goes away, well, we'll retry it in a little bit and make sure we don't lose the transaction from that end. We're connecting directly to the PG pool. So the PG bouncer. So that way we know that we're always sending the right transaction to the correct primary. And we'll see that these transactions get replicated over. So again, nothing up my sleeve. So it's a fairly simple application, nothing to write home about. Everything seems fine. So if we connect to, again, we're connected to our primary. See, everything's getting inserted, every 2 seconds overall, or 2 seconds and change. And yeah, it's life is good. So there's a function called PG is in recovery, which basically tells you if you're a standby or not. So if this is false, then you are a primary. If this is true, then you are a standby. So just to show, again, there's further nothing up my sleeve. Let's connect to the PG2 node. Yep, this is the node. They're being inserted, great. So let's connect to one of the standbys. Say it's, let's go to PG1. This one is in recovery, but we see the data is getting replicated over. And just to show there really is nothing on my sleeve, I'm going to run that same command. Try to corrupt it. Nope, cannot execute insert in a read-only transaction. That's typically the message you get from a Postgres replica. So everything's good. We're inserting our data. Everything seems healthy. Let's actually click in and see if we can see a little bit more. Yep, we see, we're collecting some data. Our database size is very slowly increasing. There's not that much replication lag. Just maybe a quick moment, but it seems to have passed. Yeah, everything seems good. Seems healthy. So let's bring it down.
Front row.
Yeah. Let's see. Overview. So I'm going to take out. So I'm going to do like the full node takeout. And the way I'm going to do that is I'm going to restart it. Remember the name of the node. I'm going to do a reload because it's going to end up restarting it and bringing it back. Let's see what happens to our connection while that's occurring. Yep. Connection terminated. Uh-oh. So first off, we need to detect that failover is happening. So we can see PG Monitor has detected AWX PG2 is down. So we need to make a promotion. Now, part of Petroni, during the election, this is actually part of the wrapped algorithm as well. You can basically choose what your heartbeats and your timeouts are, so you know when you actually want to do a failover, because there is a cost associated with a failover. And as you see, we were able to fail over fairly quickly. And we begin resuming, inserting our rows. And we want to make sure we didn't duplicate that insert, during the reload. Let's see what got promoted. Okay, so PG3 got promoted, and you're seeing that it looks like we might have a split brain 2 primaries, but this is mostly because the exporter hasn't scraped yet that PG2 is now a replica. As you see, PG2 has been brought back up. It's not been allowed to rejoin the cluster yet, though. It's still in the process of healing. So in the meantime, so one of the key things with the application that ran is notice that we were able to recover and start immediately going to the new connection, but I didn't have to update the IP address. That's because I was connected to the pool. Sorry, the PG bouncer. There's another tool called PG pool, but we're not using that. Use PG bouncer. So let's go to our new. Let's see, our new primary is 3. So everything is there. Now, important thing. Let's see if our duplicate transaction occurred. So remember that. Oops. Far down. The 77 was the one that we were worried about being duplicated, right, or being lost. But notice that there's a little bit of a time gap between 76 and 77, but 77 did go in, and it's there only once. So what about on the old primary, the PG2 node? Well, we would expect, there might be a risk that it didn't heal properly, and that transaction's still there, but nope. Everything's okay. Everything's consistent. Magic. Matt is making a face like this is magic.
Yeah, just a 22-second gap, and that's it.
Yeah.
All the transactions are there.
Yeah. Yeah, and and again, the thing was, we were able to hold our connections up before, sending more of the transactions over. And some of that is some smart application development you need to do, but you're able to at least tell PG Bouncer to not route, bad traffic, during a failover scenario.
Data loss is bad.
Data loss is bad. The one thing, in terms of, things that you can't recover from, data loss, if it's truly lost, you can't recover from that. Split brain I always put up there as being one of the worst ones, and corruption. Those are the 3 you really want to guard against, and this is what we've been able to do. We see everything. Well, let me just show you that this resets. Yep. So this is reset. This is healed, and we're back. We're back to having primary and 2 replicas. Everything is up and healthy.
We have another question coming in from the chat.
Sure.
Looks like we're at a good point here. Prem is asking, what's the difference between Crunchy certified Postgres compared to regular Postgres? Do you have any mapping in Crunchy certified version to the regular? Suppose if they just wanted to use regular Postgres 9.6, do they have to have the same version for it to be Crunchy certified?
So Crunchy certified Postgres is just regular Postgres. It's upstream Postgres. It's not a fork. Basically, it's just common criteria certified. And what we did is, as part of the certification, we had several extensions certified as well, such as the PostGIS library, which is very popular for geospatial solutions, the JDBC driver, which is very popular in enterprise deployments, PG Backrest, and PG Audit. But you can basically put that all together yourself on your own. But with the certified solution, that there's certified binaries, there's certified packages, everything that we love to hear in the enterprise world. In terms of configuring it, there's certainly a guide. We have several guides that actually are freely available for how to configure a secure Postgres environment, such as this is Secure Technical Implementation Guide, the STIG, as well as the CIS benchmarks, which we helped co-author with the Center for Internet Security. So the long story short is that this is Postgres. The certification is that the packages are certified, but this is the same as Postgres, and even the Crunchy HA Postgres solution works with the regular upstream Postgres PGDG packages as we call them. You can also use the trusted Crunchy packages as well.
Could you also explain the support/licensing or subscription model for the folks on the phone?
Yeah, so I think that's actually a better question for one of our salespeople, and I will provide some information for how to to reach out to them as well. Typically we do similar to Red Hat, we support subscriptions, and they're typically on a per core basis. But I will defer to our very fine sales folks who can not only talk more about that, but also provide an even more in-depth demo, for instance, showing an Ansible tower hooked up to the solution and watching it fail over. We actually had that demo live at Ansible Fest. And again, I'm unfortunately subject to, my colleague had way more RAM in his computer than I did for that demo.
Back to the dashboard.
Back to the dashboard. Oh, I was just having some eye candy. I can continue onward. So I'm debating if I should turn off my script. We'll just, all right.
So right now we're at 12:50, 10 minutes to the top of the hour.
Good, because we're almost done. Perfect.
So we'll hopefully have a few more minutes and we can actually open up the line to Q&A.
Sure. So we hand-waved an example Ansible inventory file for deploying Crunchy HA Postgres. But we did see the inventory file. We did not see it run. Running, it basically looks like any other Ansible deployment. Lots of colors and letting what's going on. We saw the cluster provisioned with all the instances that we needed. Everything was set up correctly. Like as soon as I went in, like it just worked. And by the way, even after I just provisioned the cluster, when I connected to the PG bouncer, it just worked. I started running transactions immediately. It was awesome. We saw Postgres operating normally. Like we went to our mounting dashboard, everything was healthy, and then we took out the primary node and we saw everything heal. I mean, if you want to, we could take out another node. Maybe during Q&A we'll do that.
Chaos monkey.
Yeah, we'll do chaos monkey. Well, I mean, there's only so much you can protect against. I mean, if all three Postgres nodes go down, you're going to go down. But it's a game of probabilities at the end of the day. And of course, you got to be smart how you deploy your nodes too. You want them to be on, adjacent networks, or different hardware. You need to be able, there is some intelligence you need in terms of how you strategize your architecture or deploying your architecture. But this makes it, once you've done that, this makes it very easy to deploy. So what's next? So one of the takeaways is that Postgres can be used for mission-critical applications. And, the Crunchy HA Postgres solution automates this process. We're able to properly get, much like that herd of hippos, in the picture, that you can quickly set up a very durable, resilient production Postgres environment. You can get a much more fuller demo. You can even see everything get set up from one of our talented solution architects or someone on our by emailing info@crunchydata.com. Like I said, at Ansible Fest, we had the live demo of Ansible Tower working, 100% behind the scenes, even as, we had a Chaos Monkey equivalent going down and, knocking nodes down. We also, can show controlled switchovers. So for instance, during, applying all the great bug fixes coming out this week, in the latest Postgres release. Actually, we'll also be at OpenShift Conference in San Diego. Like, I will personally be there. And I'd love to tell you about one of the things that I've been working on that leverages Crunchy HA Postgres, called the Crunchy Postgres platform, that lets you deploy Postgres anywhere from a single dashboard. And to show the marketing slide around this, basically that's the layer on top of what all of our other solutions do, be it with containers or Kubernetes or Ansible automation. Basically, it's a one-size-fits-all user interface that lets you deploy Postgres however you want it. That's it for me.
Awesome. Thank you so much, Jonathan.
Yeah, thank you, Matt.
All right. At this point, I'm going to open up the floor to questions. And
I might knock out another node.
well, he's destroying the cluster he just so awesomely built up. If there's any question, here we go. What is the relationship between Ansible Tower and Postgres HA? Do you need one for the other?
So you can run Ansible Tower without Postgres HA, but then you have a single point of failure where, if your Postgres instance goes down, your Tower instance will go down.
Whereas other parts of Tower are built to be resilient. You can actually have multiple masters, and you can have, delegation nodes. The backend database to Tower, like Jonathan just said, is the single point of failure. Everything else in Tower can be made HA, but Crunchy has actually filled in the gap by making the database HA. So taking Tower to all new heights.
Excellent explanation.
Any other questions? We'll have a couple minutes here.
Came back up again. Amazing. I love it.
Yeah, we definitely wouldn't want to demo it if it wouldn't come back up, right?
Yeah.
All right, well, I'm going to stop recording at this point in time. If you can put that raffle slide back up there for a second.
The most important slide.
Yeah. Please remember, everyone, thank you so much for attending. If you go to this link, you can enter for a chance to win a free $50 Amazon gift card. Those of you that are interested in the recording, you can email me directly at mstonge@redhat.com. That's mstonge@redhat.com. And thank you very much for attending.
Thank you, everyone.